Hello, friends. Welcome to Hydraulics and Hydraulic Machines class. In today's lecture, let us discuss on the reciprocating pumps, its classification, and its working. Working in the sense, the components and working. So, this we will complete in today's lecture. Pumps are, what is a pump first? Let us go to that. What is a pump? A pump is a mechanical device. A pump is a mechanical device which converts mechanical energy to hydraulic energy. A pump is a mechanical device which converts mechanical energy to hydraulic energy. What do you mean by hydraulic energy? Hydraulic energy is equal to gamma QH, where gamma is the specific weight, Q is the discharge, and H is the net head on the pump. So, if you want to operate a pump has to be always coupled with a motor. A motor converts electrical energy to mechanical energy, and that mechanical energy is the input to the pump, and the pump converts that mechanical energy to hydraulic energy. The pumps are broadly classified under two headings. Number one is called positive displacement pumps. Positive displacement pumps. And number two is rotodynamic pumps. Rotodynamic pumps. The example for the positive displacement pump is the reciprocating pump. The example for the rotodynamic pump is the centrifugal pumps. We started with the rotodynamic pumps, that is centrifugal pump. We explained the principle, we explained the components, we explained the work done, efficiencies, and all the related items. Now, in today's class and in the subsequent lectures, we focus on the reciprocating pump. So, as a first lecture in reciprocating pump, let us focus on the classification of pumps, and number two, basically the components of pump. Number three is the working of centrifugal pump. This we will finish it now. So, reciprocating pumps. I already mentioned the pump are classified into two types. One is positive displacement pump, and the second one is rotodynamic pump. This positive displacement pump is the reciprocating pump. This is the centrifugal pump. What is a pump actually? It is a device which converts mechanical energy to hydraulic energy. And what is hydraulic energy is equal to gamma QH, specific weight, discharge, head. Then coming to reciprocating pump. What is reciprocating? That means actually the to and fro motion of the piston inside a cylinder raises the pressure head. In centrifugal pump, the rotation of impeller which impress centrifugal head raises the pressure head. Pressure head, you call it as pressure energy, whatever it is. So this already we have completed. Now let us go into this. You see the word to and fro. That is why it is called as reciprocating. That means front and back movement of the piston. There is a piston which moves front and back, front and back. Inside what? Inside a cylinder. So the movement of the piston front and back to and fro inside a cylinder raises the pressure head. That is the principle of basically the reciprocating pump. Then let us take what is the classification of reciprocating pumps. The classification. The classification of the reciprocating pump is number one is based on the water being in contact with the piston. What do you mean by that? Based on this, we call it as single acting pump. We call it as single acting pump. And number two is double acting pump. What do you mean by single acting pump? If the liquid is in contact with the piston on one side of the piston in cylinder. If the liquid, if suppose you are lifting water, if water is in contact with the piston only on one side of the piston, then we call it as single acting pump. In the double acting pump, if the liquid is in contact with the piston on both sides of the piston in cylinder. If suppose the water, you take the liquid, if the water is in contact on both sides of the piston inside the cylinder, on the left side and on the right side of the piston. Then we call it as double acting pump. Generally, the double acting pump is being used to increase the discharge. Similarly, see, and the second classification is based on the number of cylinders. If suppose there is only one cylinder, then we call it as single cylinder pump. For example, there are two cylinders, double cylinder pump. If suppose there are three cylinders, we call it as three cylinder pump. If we have basically four cylinders, then we call it as duplex, double acting pump. And if suppose we have five, then we call it as quintuplex pump. The single acting pump is also called as just one cylinder. The double acting pump is also called as it is two throw pump. Two throw pump means there are two cylinders. This is three throw pump. And this duplex double acting pump is called as four throw pump. All this is based depending on the number of cylinders. It is called as five throw pump. So these are the two classifications of the reciprocating pump. The next topic for us is what are the components of a centrifugal pump? Sorry, components of reciprocating pump. I'm sorry. Reciprocating pump. The components of reciprocating pump are number one, first one is a cylinder inside which a piston will be moving to and fro. So these are the two. Then three, suction valve. Very, very important. Four, delivery valve. Next, suction pipe, delivery pipe. The last is the main thing which actually for the entire mathematical analysis, this is the thing, the crank and connecting rod. Crank and connecting rod mechanism operated by a power source. That is what we call it as motor. So these are the seven components of the reciprocating pump: cylinder, piston, suction valve, delivery valve, suction pipe, delivery pipe, crank and connecting rod mechanism. Now I will show you how they are being arranged actually. So when you are drawing the figure, kindly remember that the first thing that you should understand is the cylinder. You should draw it. So I am drawing the cylinder. So this is the way you should proceed. First is cylinder you draw. This is the first. So when you are drawing the cylinder, then naturally there is a piston. This is the piston. And this is the piston rod. Right? From the I will just a little bit extension I will make better. Okay, this is the piston rod. Then actually on this side of it, the suction pipe is connected, and on this pipe side of it, the delivery pipe is connected. Okay? This one is suction pipe, the other one is delivery pipe. This is where the suction valve is present. This is where the delivery valve is present. So, and now the suction pipe is in the sump. So, this is the sump, right? And this is the delivery from here. So now if you take it for this is the first one is what for us? Cylinder, you know it. Then the second one is what? Piston, you know it. Third one is what? The suction pipe. Then the fourth one is the delivery pipe. Then basically the suction valve 3 and 4, and this is 5 and 6, right? Then the last one, how we will make it. This is drawing first because the connecting rod and crank mechanism. So this is the crank. This is the center crank, and this is the connecting rod. Connecting rod, crank. Right? Now again I will explain. So sump, then cylinder, then basically piston, suction valve, suction pipe, delivery pipe, and then if you take the head up to the center of it, this is called the suction head, and this is called the delivery head. So I think you can write the components names once again. Right. Now, after knowing the components, how the functioning will take place, how the working of a centrifuge, the reciprocating pump takes place. Initially, the crank, this is what I told, crank. Initially, the crank position is here, right? This is what we call it as inner dead center. Inner dead center. The crank position is exactly here. When the crank position is here, the piston will be here. This is the position. That means completely closed. When the crank position is at the inner dead center, the piston position is completely at the beginning of the cylinder. Now, because of the motor, the crank starts rotating. When the crank starts rotating, this angle we call it as theta, right? When the crank starts rotating, the suction valve gets opened up and the water is being sucked into the cylinder. It need not be water, it can be any liquid. The liquid is sucked into the cylinder because of the partial vacuum in the cylinder. That is the second point. What is that point? When the crank starts rotating, because of the external energy, the suction valve gets opened up and then the liquid enters into the cylinder. So when the angle is theta, This is what the original position I have shown the previous diagram position. The piston is in this position. At this time, when the suction valve gets opened up, automatically the delivery valve is closed. Only one valve gets opened up at the point. If suction valve is open means the delivery valve gets closed. Then water enters into the cylinder. Right? Now you see when this crank reaches to this position, that position means what? Theta is equal to how much degrees? 180 degrees. Theta is equal to how much? Up to here. So the total angle is how much? 180 degrees. And this is called as outer dead center. So when the crank reaches to the position of the outer dead center, that is theta is equal to 180, the piston reaches to the extreme right. So this is the position of the piston. When this is the position of the piston, you now tell me what is the entire cylinder is now filled with what? With the liquid. With the liquid. So that means when theta is equal to 0, that is what we call it as inner dead center, and theta is equal to 180 degrees, which is the outer dead center. When theta is varying from 0 to 180 degrees, the suction is happening and the liquid is entering from the source sump to into the cylinder. This is what we call it as suction stroke. This is what we call it as suction stroke. Suction stroke happens from theta is equal to 0 to 180 degrees. Right? Now the cylinder is completely filled, right? And remember, the liquid is in contact with the piston only on one side, because on this side only, on this side of it only, the what the liquid is connected. So that is why we call this as single acting reciprocating pump. Single acting pump. Why single acting pump? The liquid is in contact only on this side, right? And only on this side only the liquid is in touch with the piston. On the other side of the piston, the liquid is not there at all. The piston only moving front and back, front and back. When theta is equal to 0, it is the extreme front position. That is what I call it as extreme left position. When theta is equal to 180, the piston is at the extreme right position. So during this, that means from theta is equal to 0 to 180 degrees, the suction valve is open, the delivery valve is closed, and the liquid is being sucked into the cylinder, and the cylinder gets filled with the liquid. This is what we call it as suction stroke. Now, at the end of the suction stroke, that is when theta is equal to 180, the piston is at the extreme right position. Now, again from theta is equal to 180 to 360 degrees, because 180 to 360. So it rotates like this, right? And again it rotates like this. So theta is equal to 180 to 360. What will happen? The piston pushes the liquid to a forward. The piston pushes the thing. That means the piston actually moves from this position towards basically the left. So that is what is happening. So by the end of 360 degrees, that means when the crank comes rotates about 360 degrees, which is nothing but theta is equal to 0. Again, the piston has reached to the extreme left position. This is what we call it as the delivery stroke. Theta is equal to 180 to 360. So in this stroke, what is happening? The liquid is being pushed actually by the piston. When the moment the piston starts pushing it, the suction valve gets closed. The moment the piston starts pushing the liquid, automatically the suction valve gets closed and the delivery valve gets opened up. When the delivery valve gets opened up, this liquid from the cylinder, it flows into the delivery pipe. So this is the way it functions. In one rotation of the what you call it as the crank, one rotation of the crank from theta is equal to 0 to 360, then the piston moves actually from the extreme left to right and from extreme right to left, and it completes two strokes. One is suction stroke and the other one is delivery stroke. During the suction stroke only it sucks the liquid, whereas in the delivery stroke it only delivers the basically the liquid. So during the entire operation, that means during the entire rotation of the crank, one rotation of the crank, there is only one suction stroke, one delivery stroke. During the entire suction stroke, no water will come out from the delivery pipe. During the delivery stroke only, the liquid will come out of the delivery pipe actually. So this is the fundamental, the way how a reciprocating pump functions. The moment you see it, now you understand that actually the to and fro motion. So now you see when the crank is rotating because of the external source, the piston is moving forward and backward. So during the suction stroke, it moves like this actually. The piston moves backwards, whereas during the delivery stroke, the piston moves forward. So this movement of the again next 360 degrees, if you say again suction, again delivery, again suction, again delivery. So this process continues actually. Thereby, there will be continuous delivery of water or liquid that takes place. So this is how the working of a reciprocating pump. If suppose I plot how the discharge, the variation of discharge through delivery pipe in case of a single acting. Single acting, I mean, already I mentioned what the liquid is in contact of the piston only on one side. Is shown as, suppose if I plot, x-axis is crank angle theta and y-axis is discharge. If I plot like that, x-axis is crank angle, y-axis is that. Now if I take it actually, this is crank angle is 0, 0 degrees, 90, 180, 270, 360. This is one rotation of the crank. If I take it, how it will run. So if I take it during this first suction stroke, what is happening actually? Only the liquid is being sucked. So delivery starts from where? Delivery starts from here. That means at 180 degrees. So here the delivery starts. This is how the delivery starts. So this is what the cue. Whereas during this stroke, this is only suction stroke, only sucking the water. There is nothing, and this is the delivery stroke. So during delivery stroke only, the liquid is being delivered. So this is fundamentally the single acting reciprocating pump. Suppose if you take a double acting pump, I told in the double acting pump, the liquid is in contact on both sides. See how I am drawing, because drawing figure is very, very important. So this is suction pipe, this is delivery pipe. This is suction pipe, this is delivery pipe. Understood? Now the piston is here. Rest of the figure is same. So only thing is two suction pipes, two delivery pipes. Again, balls. So now if you see the first suction pipe, second, second set, what will happen when first thing is at the extreme left, that is at theta is equal to 0, right? The piston is at the extreme left. Now, when theta is equal to 180, the piston reaches to this extreme right. This is the extreme left, this is the extreme right. Right? When it reaches like that. So in the first, when theta is equal to 180, then the liquid is being sucked into the cylinder. Right? Right. When the theta is equal to 180 to 360, it is delivered. When it is delivered, the piston is being pushed forwards. When it is pushed forwards, the other side there is a suction pipe. Automatically here the vacuum will be there, partial vacuum. So when vacuum is here, automatically the liquid is being sucked on this side. That means the delivery stroke for the suction pipe and delivery pipe of set 1 will be the delivery stroke for it. Now what will happen again when you are pushing back, or it is being moving back, the fluid is being discharged. Now if I draw how it flows, because water is in contact on both sides, water rather than water, liquid is in contact both sides. So when that means always water is there. This is theta is equal to 0, 90, 180, 270, 360. The suction stroke of the first set of pipes is the delivery stroke for the second set of pipes. That is the first thing you should understand here. So in both the strokes, the discharge is being delivered. If suppose if it is the suction stroke for the first set of pipes, it will be the delivery stroke for the second set of. And when it becomes the suction for the second set, then it becomes basically the delivery for the first. That means always there will be delivery in this case. So that is why, that is the basically the advantage of the double acting pump. The discharge in the case of double acting pump is that is the only thing, absolutely nothing beyond that. In the discharge in the double acting pump, the discharge is equal to 2 times the discharge of a single acting reciprocating pump. So why? Because both the strokes are being utilized for delivery. The suction stroke for first set of pipes is the delivery stroke for the second set of pipes. The suction stroke for the second set of pipes is the delivery stroke for the first set of pipes. So thereby in both the strokes, water is being or liquid is being delivered in the case of double acting pump. The only thing is when for mathematical calculations, what is the advantage the double acting pump is? In the case of a double acting pump, the discharge is equal to twice the discharge of the basically single acting reciprocating pump. So in today's lecture, what we have discussed, just once again, let us brush actually what are the topics that we have discussed. We started with the reciprocating pump, and then we explained the principle of reciprocating pump. We explained the components of reciprocating pump, and we explained the classification of reciprocating pumps. Finally, we explained the working of the reciprocating pump. With this, we will stop this lecture at this stage. Thank you so much. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.